Hello everyone. In today's video, we are going to solve a question related to related rates. The question is about a conical tank with a vertex down and a radius of 10 feet at the top and 24 feet of height. So the first thing is we always start out with a diagram in such related rates questions. So this radius is given as 10 feet and this height over here is given as 24 feet, which is the initial height. They're saying that if the water flows out of the tank, so the rate at which it's flowing out is 20 feet cube per minute. And how fast is the depth of the water decreasing when the water is 16 feet deep? So, after a certain point, what's going to happen is the water will keep coming down, and then there would be a, let's say if this was 16 feet is the depth of this water, then what is the rate at which the height or the depth of the water is decreasing? So essentially they're asking us to find dH over dt. Now first thing is we should write down all the information that we have over here. So r at that given instance is given as 10 feet, and the initial height of the water is 24 feet, and then the rate at which the volume is decreasing or coming out of the tank would be 20 feet cube per minute. Now we know that the volume of a cone is given by the formula V is equal to 1 by 3 pi r square h. So first thing is that since we have two variables r square, r and h, we need to kind of figure out a way to eliminate one of the variables. In this case, I will be eliminating r because h is something that we already need to figure out. We need to find out dH over dt. So the most common relationship in such problems is if I make a triangle over here, if this is my 10 feet is my initial height and 24 feet is my 24 feet is my initial height and 10 feet is my radius, then if my new radius is r and new height is h, then the relationship, since they're similar triangles, would be r over 10 can be written as h over 24 because the sides of the triangle would be proportional to each other. So with this we get a relationship that h is equal to, or r is equal to 10 by 24 h, or I can write this as 5 by 12 h. Now that we have a relationship between r and h, all I'm going to do is put this value in here and substitute the volume formula and rewrite it. So the new volume formula is going to be 1 by 3 pi 15 by 12 h whole square times h. Now we're just going to simplify this a bit more. So this would be 1 by 3 pi times 25 by 144 h cube. Now once we've written it in this format, we can go ahead and differentiate. So we have dv by dt is going to be 1 by 3 pi 25 by 144 times 3h square. Now this 3 and this 3 can be cancelled out. Also we have dH over dt, let's not forget that. So now we have pi 25 pi by 144 h square dH over dt. We already know in the question they've given us that dV by dt is 20 feet cube. So I'm just going to write 20 is equal to pi 25 pi 144, and then at that given point h is going to be equal to 16, so you can put in 16 as well over here. So 16 square dh over dt, and then now we are just going to go ahead and solve this. So we'll get dh over dt is equal to 20 times 144 divided by 25 pi times 16 square. You can go ahead and put this in the calculator, and the answer that you get would be 0.0043 feet per minute. So this is how we solve these related rate problems. If you like my video, please go ahead and hit the subscribe button, like and share. Thank you so much.